Hi everybody, Mrs. Pesic here. We are looking at Chapter 5, which is called Rational and Radical Functions, and we're looking at Section 5.1, which is called Variation Functions. The learning objective for this lesson, which you do not need to write down, is to solve problems involving direct, inverse, joint, and combined variation. Let's start with direct variation. You did learn about direct variation in Algebra 1. It's just a special type of a linear function. A direct variation is a relationship between two variables, x and y, that can be written y equals k times x when k is not equal to 0. So some examples of a direct variation might be something like y equals 2/3 times x, or y equaling negative 5x. Those would be examples of direct variation equations. The k is called the constant of variation. For the equation y equals kx, y is said to vary directly as x. So notice y equals kx looks a lot like y equals mx plus b, but there's no b. That means the b must have been equal to 0. All right, and the k is really just your slope. So in y equals kx, it's just a linear equation that has a slope of k, whatever the k is the slope, and the y-intercept is 0. Because b is equal to 0 in this linear equation, the graph of a direct variation always passes through the origin. So if we were graphing, for example, y equals 2/3 x, which is a direct variation equation, the graph would go through 0, 0, and it would pass through the ordered pairs 0, 0. If I plug in 3, for example, I would get 2 as the output, so it goes through 3, 2. It would look like a linear function going through 0, 0, and 3, 2. All direct variation equations will pass through 0, 0. Let's take a look at an example. Given y varies directly as x, and y equals 27 when x equals 6, write and graph the direct variation function. As soon as you see that y varies directly as x, you should immediately write down your equation, which is y equals k times x. You know that y is equal to 27 when x equals 6. So if you plug those values in and you solve for k, you get k equals 27 over 6, which, let's see, 3 goes into this twice, 3 goes into this 9 times. Looks like k is equal to 9 over 2, which is the same as 4.5. We're not done yet. We need to write the direct variation function. This is just the k value. So we're going to take that k value and we're going to plug it in right here. So we're going to get y equals 4.5x. And if we're going to graph this direct variation equation, our graph would look something like this. We know it goes through 0, 0, and if we plug in, for example, 1, we would get 4.5. There's 1, 1, 2, 3, 4, 5, and we get 1, 4.5. So the graph would look something like this. All right. Now, here's your first notes must do. It is just like this one, so follow that as your guide. Y varies directly as x. When y equals 6.5, x equals 13. Write and graph the direct variation equation. By the way, remember back here, this was your direct variation answer right here. This was your direct variation equation, and then I did the graph. When you're done with this notes must do, please continue with the notes. All right, we're moving on. Direct variation. Think about it this way. As one quantity goes up, the other quantity goes up. And if one quantity goes down, the other quantity goes down. All right, now for joint variation. Joint variation is a relationship among three or more variables that can be written in the form y equals k times x times z, where k is the constant of variation. For the equation y equals k times x times z, y is said to vary jointly as x and z. Let's take a look at an example. The volume V of a cone varies jointly as the area of the base, B, and the height, H. Let's say that the volume is equal to 12 pi cubic feet when the base is equal to 9 pi square feet and the height is equal to 4 feet. Find the base of a cone if the volume is 24 pi cubic feet and the height is 9 feet. So let's start with what we see. We see that V, the volume of the cone, varies jointly as the area of the base and the height. As soon as you see that something varies jointly, you can write out your equation. So we're going to write V equals K times, V is the volume, K is our constant of variation, K times B times H. And we're going to fill in the values that we were given here. Volume is 12 pi, base is 9 pi, height is 4. So if we fill those in, we get 12 pi equals k times 9 pi times 4. 9 pi times 4 would be 36 pi times k equaling 12 pi. And we divide both sides by 36 pi to get k by itself. And over here we see that the pi's divide out and 12 goes into 12 once and 36 three times. So we get a k value that is equal to 1/3. So we're going to plug in that 1/3 value in for the k. So our equation that relates the volume, the base, and the height is V equals 1/3 the base times the height. Now we can use that equation to answer the question. Find the base of a cone if the volume is 24 pi cubic feet and the height is 9 feet. So the volume is 24 pi. Let me write my equation down again. V equals 1/3 base times height. The volume is 24 pi, and that's equal to 1/3 times the base. We don't know, but the height is 9. Well, I know that 3 goes into 3 once and into 9 3 times, so 1/3 times 9 is 3. I still have the base B that I need to find, equals 24 pi. We divide both sides by 3, and we end up getting the base is equal to 8 pi. And you should give the correct units. The base is 8 pi square feet. The height was a linear unit, the base was an area, so square feet, and the volume of the cone, of course, would be in cubic feet. All right, a third type of variation describes a situation in which one quantity increases and the other decreases. For example, this table shows that the time needed to drive 600 miles decreases as the speed increases. So let's compare the speed, the time, and the distance. Let's say we were only traveling 30 miles per hour. It would take us 20 hours to get 600 miles because 30 miles per hour times 20 hours would be 600 miles. If we increase our speed to 40 miles per hour, we would only need 15 hours to go 600 miles. And if we increase our speed to 50 miles per hour, we would only need to be traveling for 12 hours to reach 600 miles. This type of variation is an inverse variation. An inverse variation is a relationship between two variables. That's supposed to say x and y, that can be written in the form y equals k over x, where k is not equal to 0. For the equation y equals k divided by x, we say that y varies inversely as x. So if you see two quantities varying inversely, you're going to want to immediately write down this equation, y equals k divided by x. Let's take a look at an example. Given information is that y varies inversely as x, and y equals 4 when x equals 5. Write and graph the inverse variation function. Again, as soon as you see that y varies inversely as x, you're going to want to write this equation down. So let's write down y equals k divided by x, and we're going to fill in the 4 for y and the 5 for x. So we get 4 equals k divided by 5. Let's find that k value by multiplying both sides by 5. We get k is equal to 20, which means our equation is y equals 20 divided by x. That's our answer. And when we do a graph, we could plot a few points so you see what's going on. If I choose x to be 1, y is going to be 20 divided by 1. That's 20. If I choose x to be 2, I get 20 divided by 2 is 10. If I choose x to be 4, 20 divided by 4 is equal to 5. Notice as my x values are going up, 1, 2, 4, my y values are going down, 20, 10, 5. So when we graph this, it's an interesting graph. Let's graph it on the calculator. We're graphing y equals 20 divided by x. So if I graph 20 divided by x on my calculator, I get this interesting graph. This is not a linear function. We see that we've got one part of the graph up here in the first quadrant and another part down here in this quadrant. If I was to plot 1, I'd have to go up to 20, 2 would go to 10, 4 goes to 5, 5 goes to 4, and so on. And I would also have negative 1 goes to negative 20, and so forth. That is how the graph of an inverse function looks. All right, here's your notes must do number 2. On this notes must do, you're given that y varies inversely as x and y equals 4 when x equals 10. So write and graph the inverse variation function. And it's okay to graph this on your graphing calculator. Remember, as soon as you see that y varies inversely as x, you're going to write down a certain equation and you're going to plug things in. When you're done with this notes must do, go ahead and continue with this video. Okay, let's take a look at this. We are comparing now direct variation with inverse variation. Direct variation, remember the equation for that is y equals k times x. But if we wanted to, let's say, divide both sides of that equation by x, we would end up getting this equation, that is y over x equals k. Both of those would be direct variation equations. When you divide y by x, you're going to get a constant for a direct variation equation. Let's take a look at the inverse variation. Inverse variation equation is y equals k divided by x. That's not the same as y over x equals k. If you have y equals k divided by x and you choose to multiply both sides by x to get the k by itself, we would end up getting this new equation, x times y equals k, which again is not the same as y equals k times x. In inverse variation, when you multiply x and y, you always get the same constant. All right, let's take a look here. This is your third notes must do. Identify each of these variation equations as being direct or inverse. So here are your examples. For number 1, it's y equals 4 divided by x. I just need you to tell me, is that direct variation or inverse variation? Simple, right? And number 2, y divided by x equals 4. Is that direct or inverse? Number 3, x times y equals 3. Is that direct or inverse? And number 4, y equals 3 times x. Is that direct or inverse? When you're done with that, please continue this lesson. All right, let's take a look at this example. Determine whether each data set represents a direct variation, an inverse variation, or neither. Let's take a look at this first data set. X is 6.5, y is 8. X is 13, y is 4. X is 104, y is 0.5. This one is going to end up being an inverse relationship. First of all, notice the x's are going up, the y's are going down, but that's not enough to make it inverse. You actually have to be able to multiply the x's and the y's together and get the same answer each time. And as it turns out, 6.5 times 8 is equal to 52. And 13 times 4 is equal to 52. And 104 times 0.5 is equal to 52. Since that happens for all of them, that the x times the y is equal to a constant, then it is an inverse variation, and our equation for this data would just be x times y equals 52. Let's take a look at this next one. 5 goes to 30, 8 goes to 48, 12 goes to 72. I see that x's are going up and the y's are going up. So it sounds like it might be a direct variation, but we don't know for sure unless we actually do the dividing. Is 30 divided by 5 equal to 48 divided by 8? And is that equal to 72 divided by 12? Yes. Y divided by x is equal to 6 for each of these. So that's why we would say it's a direct variation equation. 30 divided by 5 is 6. 48 divided by 8 is 6, and so on. So it's a direct variation. How about this one? 3 goes to 5, 6 goes to 14, 8 goes to 21. Well, the x's are going up and the y's are going up. So you might think that it looks like direct variation. But the answer is it's neither, because notice if we try to divide 5 by 3, is that equal to 14 divided by 6? And the answer is no. 5 divided by 3 is really 1 2/3. Is that equal to 6 goes into 14, 2 2/14 worth, 2 1/7? They're not equal to each other. So the answer is neither direct nor inverse. All right, one last type of variation that we need to look at, and this one is called combined. A combined variation is a relationship that contains both direct and inverse variation. Quantities that vary directly appear in the numerator, and quantities that vary inversely appear in the denominator. So let's take a look at this example. The volume V of a gas varies inversely as the pressure P and directly as the temperature T. All right, I tell you what, let's just take that first sentence and write an equation based on that before we look at the rest. The volume V of a gas varies inversely. So we're going to want V equals some constant over something. It varies inversely as the pressure, so I'm going to want pressure in the denominator, but it varies directly as the temperature, so I want temperature in the numerator. So our equation should be V equals some constant K times T divided by P. A certain gas has a volume of 10 liters, a temperature of 300 kelvins, and a pressure of 1.5 atmospheres. If the gas is compressed to a volume of 7.5 liters and is heated to 350 kelvins, what will the new pressure be? So to answer this problem, let's fill in what we know from the given information. We know initially that a certain gas has a volume of 10 liters, a temperature of 300 kelvins, and a pressure of 1.5 atmospheres. So if we fill that into our equation, we will have 10 is the volume equals K times a temperature of 300 kelvins, and 1.5 atmospheres is the pressure, so that goes here. All right, and so when we are solving for our K, we can do 300 divided by 1.5. 300 divided by 1.5 is 200. So that means we really have 10 equaling 200 times the constant. And if we divide both sides by 200, we would get 1/20th as our constant K. That means our equation here could be rewritten V equals 1/20th times T over P. And if you want to write 1/20th as a decimal, you could. 1/20th, 1 divided by 20 is 0.05. So if we write that, we can write V equals 0.05 times T divided by P. Now it's saying if the gas is compressed to a volume of 7.5 liters and it's heated up to 350 kelvins, what will the new pressure be? So let's write down that the volume is now 7.5. And so that's going to be equal to 0.05 times the temperature of 350 kelvins, and we divide by the pressure P, which we do not know. We're solving for that. So we take 0.05 and we multiply by 350. I'm getting 17.5. And so I get 7.5 equals 17.5 divided by P. Think of this as 7.5 over 1 equals 17.5 over P. I can cross multiply to solve this. So I would get 17.5 equals 7.5 P. Divide both sides by 7.5. And I get my answer to be 17.5 divided by 7.5. I get 2 1/3 as my answer. So the pressure would be 2 1/3. And the units to describe the pressure is in atmospheres. All right, that completes our notes for this section. I hope that you finished all the notes must do and took some good notes. We'll see you next time.